So let's look at another area example here. So we have a curve x is 2 cosine t and y is 4 sine t for t from 0 to 2 pi. And we want to find the area inside of that curve. Well, let's first find out what this curve is. It's got cosines and sines in it, so why don't we try and eliminate the parameter? So if you divide by 2 here on both sides, and then divide by 4 on both sides, you get that cosine t is x over 2 and sine t is y over 4. And we know that cosine squared t plus sine squared t is equal to 1. So cosine is x over 2, so that's going to be x over 2 squared plus sine t is y over 4, so y over 4 squared equals 1. So that's x squared over 2 squared plus y squared over 4 squared is equal to 1. And that is an ellipse. So the 2 in the cosine tells you the x diameter and the 4 in the sine tells you the y diameter. So we can actually sketch a picture of this guy. So it goes plus or minus 2 in the x direction and plus or minus 4 in the y direction. So 1, 2, 1, 2, 3, 4, 1, 2, and 1, 2, 3, 4. So that ellipse looks like this. And we want to find the area inside that ellipse. So, we can use some symmetry here, right? If we just find a quarter of it and then multiply by 4, then we're good to go. So why don't we find out what the t values are here? So let's do t, x, and y. And at t equals 0, 2 cosine of 0, cosine 0 is 1, so times 2 is 2. 4 sine of 0, sine of 0 is 0, so that'd be 2 comma 0, which is right here. So that's t equals 0. Let's see if this guy up here isn't pi over 2. So at pi over 2, cosine pi over 2 is 0 times 2 is 0. Sine pi over 2 is 1 times 4 is 4. So that's up here, and that is indeed t equals pi over 2. So by symmetry here, we are just going to find that area right there and multiply by 4. So our area here is going to equal the integral from 0 to pi over 2 of y dx, and our y is 4 sine t. And the differential of x, derivative of 2 cosine t is negative 2 sine t dt. So this is our y, and this is dx. And then we're going to multiply that by 4. So integral from 0 to pi over 2. We can take the 4 and the negative 2 outside. That'll be a negative 8 times the 4 out here, negative 32. And then we've got left our sine t and another sine t, so sine squared t. And so that's trig integral. So what do we do with sine squared? That's right, half angle identities. So we are going to trade that out. Oops, that's a pi over 2. Going to trade that out, 0 to pi over 2. And this is going to be 1/2 1 minus cosine 2t. And so let's see, the 2 here will cancel into the 32, give us 16. So this will be negative 16 out in front. And now we can integrate this. So it's going to be t, antiderivative cosine 2t is 1/2 sine 2t. And we're going to integrate, we're going to substitute in from 0 to pi over 2. So we got that negative 16 out in front. If we plug in pi over 2 here, we get pi over 2 minus 1/2 sine 2 times pi over 2, that's sine of pi. And then minus, if we plug in the zeros, 0 there, sine of 0 is 0, so the zeros don't do anything else. So sine of pi is the y-coordinate of pi on the unit circle. Pi is over here, y-coordinate is 0, so this drops out to get a 0 there. And then this is just negative 16 times pi over 2. And 2 cancels in there 8 times, so this is negative 8 pi. So our area, then we change the sign, is positive 8 pi. And this is oriented this direction here. So I think the reason we're getting the negative there is because as you go in the direction of increasing t, your x is decreasing. So there's a sign change in x, but the y is increasing. Which, you know, when x increases, when you're doing y and x together, x increasing is always to the right. Here we're going back to the left. So it's the orientation of the curve that's introducing that negative sign. Now, notice here that this 8 pi is actually 4 times, well, let's do it like this. This is actually pi times 2 times 4. So if this was a circle, our area would be pi r squared. For an ellipse, it's pi times 2, which is the x radius, times 4, which is the y radius. So in general, if this is a cosine t and b sine t, then your area is going to be pi AB. So actually pi r squared is a special case of the ellipse formula for area, which is pi AB, and it's the case where the two radii are the same. So that's pretty cool. Now just a note here, note that if we would have done the integral from 0 to 2 pi, so that would have been one whole revolution, we would have got 0, right? Because we'd be plugging in 2 pi here. Let's see, I think we would have got 0. So that'd be a 2 pi. This would be 0. We wouldn't have the 16 out in front. We wouldn't have a multiplier out in front. Let's see here, would we? Oh no, I'm sorry, we'd have a negative 8 out in front is what we'd have. And times 2 pi. Yeah, no, I'm sorry. We'd have a negative 8 out in front, but then this 2 would cancel into it. We'd have a negative 4. So we'd actually have a negative 4 here instead of a negative 16, and we'd have a 2 pi here. No, we do. We get the same negative 8 pi. But this actually, I've seen this happen with some of them. Let's see here. I wonder. Oh, yeah, if we do this, let's see here. If we went on the top half 0 to pi and then double it, no, we'd still get pi out here. So that wouldn't make it cancel out. So you got to be a little bit careful here. So this wasn't the case on this one. So I guess I don't have a note there. But just a note here, sometimes you'll get canceling. So sometimes it'll count the top area here, where you're going negative x as, negative, and then the bottom area as positive, and then you can get some canceling out. So you have to watch for that. So I'll just say watch for canceling areas. All right, so why don't you try the next WebAssign problem with this example under your belt?